All right, hello everybody. In this video, we are going to continue graphing linear inequalities. This time, we're looking at a linear inequality that is not in slope-intercept form. Notice it is in standard form. We cannot graph it like this, so let's go ahead and take this, solve it for y, so we can then pull out the slope, the y-intercept, and then determine what kind of line and where we're going to shade. So I'm going to circle this just like I circled my equal sign so we can solve. We know we're trying to get the y by itself, so we're going to take the 2x, we're going to subtract it from both sides. And because 6 doesn't have an x, we're just going to set it next to it. All right, this becomes 0. This is a negative 3y, so we're going to bring that down as a negative 3y is greater than 6 minus 2x. Now, I am going to remind you that we're about to divide by negative 3. We are dividing an inequality by a negative number. So if you forgot, I'm going to remind you that we need to flip our sign. So this right now, before we divide, is greater than. When we get done, it is going to be a less than because we are dividing by a negative number. Okay, so this becomes y is less than negative 2. 2/3 does not simplify any further, but the two negatives become positive 2/3 x. All right, so from here, I know my y-intercept is negative 2. I know my slope is 2/3. Opposite slope is negative 2 over negative 3. And according to our inequality symbol, which has been flipped, this is going to be a dashed line because it doesn't have an equal to. And because it's less than, we are going to shade below our y-intercept. So we're going to shade below negative 2. All right, with that being said, let's go ahead and jump into it. Our negative 2 on our y-axis is right here. According to the slope, we're going to go up 2 and over to the right 3. So this is my 0. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. And if you want to use your opposite slope, go back to your y-intercept, count down 2, and to the left 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. Don't forget that this is a dashed line. So line up these points, make it dashed. So notice that when I go from one side to the other, I'm creating two parts of the graph. We said according to our inequality symbol, we are going to find the negative 2. And we're going to shade everything below. So according to this y-axis, everything below would be here. And so that means that we're going to shade everything on this side to represent all the points that are part of the solution set. So these are going to be as hard as these problems get, just because they take all of the steps that we have been working on lately. We have to solve for y. We have to find the slope and the y-intercept so we can graph it. And then we have to look at our inequality symbol to know what kind of line and where to shade. So this one kind of wraps up all those different skills that we've been working on individually into one problem. So just like any other problem, we need to look at our special lines. And we know our special lines are either vertical or horizontal. So I'm going to remind you to continue to use Hoy and Vux. Now, I'm going to start with this one right here just because it plays into stuff that we've been doing. And we're going to use the same languages, the same language, the same vocabulary for this problem. So the only thing we have here is a y. So between Hoy and Vux, we're going to use Hoy because Hoy is the one that has a y in it. The H in Hoy stands for horizontal. So we're going to have to draw a horizontal line, determine what kind of line, and where to shade. So with that being said, let's find positive 5 on the y-axis. So positive 5 is right here. And before I draw my horizontal line, I'm going to look at the symbol. This symbol tells me it is a dashed line. It also tells me it's greater than, so I'm going to have to shade everything above the 5. And so when I do that, I'm going to go ahead and create my dashed line, my dashed horizontal line. Now notice that as I'm drawing this horizontal line, I have an above and a below. So that fits the same language that we have been using, the same words. So we are going to shade above the 5. So everything on the y-axis above the 5 would be up here. So this is my solution set. The only problem that doesn't fit those same language that we have been using is going to be the vertical line in the other example. So because this one only has an X, we know we're using VUX. And the V in VUX stands for vertical line. So instead of drawing that horizontal line, we're going to draw a vertical line. So where? We're going to find positive 3 on the x-axis. So here's positive 3. We're going to draw a vertical line. And because this is less than equal to, we're going to use a solid line. It's less than. So we can't really say below. Because notice that when I draw my solid line, solid vertical line, it doesn't have an above or below. It has a left and a right. So you're going to have to look at your x-axis and ask yourself, where are the numbers that are less than 3? Are they to the right? Are these numbers less than 3? No. Are they to the left? And notice that these numbers here, like 2 and 0, are less than 3. So that means instead of using above and below, we're going to use left and right. So we're looking for numbers less than 3. So we're going to shade everything to the left of this line. All right, so with that, you can see that even if we have a vertical line, we can still do a solution set using left and right instead of above and below. So just know that what we normally would use as below would be to the left, and what we use as above would be to the right. So with that, that is how you graph linear inequalities using what we already know about equations, and then interpreting that inequality symbol so we know what kind of line to use and where to shade. So I hope that helped, and I will see you guys in the next